2023. This is in the Helsinki and Northern edition. My name is Jeremy Snyder. I'm the founder and CEO of FireTail. You can find us online at firetail.io. And today I'm here to talk to you about what Outliers can teach us about API data breaches. So let's begin. So preventing future data breaches is actually the goal of today's presentation. I'm going to be sharing a lot of the information that we've learned from analyzing data breaches in the past and kind of correlating that to a framework for thinking about how we frame them, how we analyze them, and how we look at improving our own processes around that. So for today's session, we've got two recommended readings. The first one will not surprise anybody. That is, of course, Outliers, the story of success from Malcolm Gladwell. And ultimately, success is what we are driving for. So let's not get caught up on too many things. We'll get into a couple different areas of exploration as we go through the presentation today. The other one I do always want to highlight is the State of the Internet report from 2021 from Akamai around APIs as the attack surface that connects us all. I think it's actually eye-opening for a lot of people, maybe not for those who are attending API days, but for a lot of people to realize that more than 80% of all internet traffic is API calls. So that's really, computers talking to computers, systems talking to systems, software talking to systems, other software in order to enable transactions, in order to process business functions, and so on. And that's going to be something that we look at a couple times over the course of today's presentation, but just keep that in mind as background information for today's presentation. I want to start the discussion with an unfortunate case study that is highlighted in Outliers, and that's the story of Korean Air Flight 801. So this was on August 5th in 1997, and it was a flight from Seoul Gimpo Airport, the smaller airport in Seoul, to Agana, the capital of Guam. Now, Guam is an island in the Pacific Ocean. U.S. territory, only has one airport. If you haven't been there, some of this will be kind of maybe a little bit new information for you, but I'll try to fill in some of the details as somebody who has had the lucky opportunity to visit there. But really, it's a flight that had a lot of problems from the beginning. So the initial captain who was assigned to the flight was unable to make the flight. So a substitute captain was put in. This captain was initially scheduled to fly to Dubai. So in preparation for the day's work shift, that captain had trained or reviewed another flight plan and had really prepared to that. And only upon reporting was this captain reassigned to Dubai. Why? Because of a work assessment that he was too fatigued to make the longer flight to Dubai. Now, a flight to Dubai from Korea is something in the 8 to 10 hour time frame, whereas a flight from Seoul to Guam is only on the order of about 3 hours or so, 3.5 hours. So we've got a last minute schedule change. So we've got somebody who is maybe not in the mindset or having done the background work in order to prepare for that day's flight. Second thing that happens is, the flight actually starts smoothly. All systems are operating normally. The crew is actually operating fine. But just outside Guam, there's an area of heavy turbulence that starts to put the crew on edge. So, of course, there are a number of upset passengers. They're worried about the rain, the turbulence, etc. Maybe they're not frequent flyers. Maybe they don't know that this is just part of normal kind of Pacific Ocean, not typhoons, but, thunderstorms. And so you've got a crew who's on edge. When they emerge from the clouds on the descent into Guam, they start to get visibility onto Guam, but then there's a second thunderstorm that hits, and that is kind of between the coast of Guam and the airport. Now, again, here, context is kind of important to understand because Guam, as a Pacific island in the kind of ring of fire, is part of a volcanic chain. So what you've got is kind of mountainous areas emerging from the sea. And they tend to have a topology that has kind of coastal plains and then central highlands on the island. That is the case with Guam. So Guam, actually, the airport is on kind of a cliffside or a hilltop towards the middle of the island. That's going to come in play, unfortunately, later, but it is just important to understand. So when you've got visibility on the island, you may not be able now to see kind of the difference in elevation between the coast that you first sight and the airport where you're going to land. Now, the next thing was, because of the rain, the captain wanted to switch over to ILS. ILS's instrument-led systems or instrumental landing system. I can't remember exactly, but it's basically not using eyesight to land, but actually using the instruments. And this is, of course, much more precise. And in fact, nowadays, as we fly in 2023, it's the standard. And it's the standard pretty much all of the time. We pretty much always use these instrument-led systems because they're so precise. GPS is so ubiquitous in the modern world. And most of our flying is powered by computer systems at this point. Unfortunately, at this time, the ILS system was not functional at Guam, and you really need two parts of it. You need the air traffic control ILS and the airplane ILS to be in sync in order to guide the aircraft in. But we had a secondary problem here. We had a communication breakdown. And in fact, there were two communication breakdowns. First was a communication breakdown between the air traffic control and the captain in terms of informing them that the ILS was not optional and they needed to go to eyesight navigation. The second one, which was actually much more impactful on the day, was that the flight's navigator informed the captain of being off course and of the inoperative ILS, but the captain ignored this person. And the book goes into a lot of analysis around this, and there are some suggestions of kind of cultural hierarchy differences, but communication styles, etc., are really a big part of the problem here. Ultimately, though, what it led to is the captain ignored the crew. So the captain set his mind towards a path of using this ILS system to land. The ILS system wasn't working, and the captain was not taking any feedback from other people. So, of course, the results were tragic. More than 200 people were killed on the date. But when we think about this, I think one of the things we need to understand is what went wrong. And this is very, very common in analysis of airplane crashes. And, Outliers I picked as an example because it gives us some great, very straightforward ways of understanding some of these challenges. So you'll notice that we had a combination of technical issues and non-technical issues. On the technical side, we had the ILS system not working. On the non-technical side, we had things like the captain's fatigue. We had things like a rainstorm affecting visibility. When we think about communication, we notice that there are kind of communication issues that didn't really surface the problems up to the level of the decision maker who ultimately would have needed to take action around that. And then finally, one of the things, and this is very parallel to APIs, is that we had both internal and external parties, right? So we had Korean Air, we had the captain, the crew, et cetera, and we also had the air traffic control at the Guam airport, and we had communication breakdowns between them. So those are some of the common threads that we see there. And you'll notice that, if any one of these things had been wrong, there were plenty of opportunities to correct. But the fact that multiple problems stacked on top of each other is really ultimately what most of the conclusions say led to the event happening. And in fact, if you look at the literature from things like the NTSC, the National Transportation Safety Board, or the International Aviation Organization, IAO, you'll see consistency even in the decades that have followed. Every subsequent plane crash, there have been multiple aspects that went wrong. And we can spend some time looking at other ones if there is time remaining at the end, but unfortunately, that seems to be a consistent trend. So how does this impact APIs and what can we learn from this? Obviously, there's no APIs directly in question, but what I thought I would do today is to pick a few case studies from some analysis work that we've done over the last several months, looking at 10 plus years of API data breaches, and try to find some parallels because they really are there. So I started with this kind of famous API security incident from 2021. And, this was Peloton. And not to go into all the details, but basically somebody looked at their Peloton traffic from their home router. They realized the API calls that were going out. They realized that they could very easily see their authentication token. They could see future arguments, looking for things like profile IDs, looking for things like data access, et cetera. And they started experimenting with that API. Could they access other profiles? Yes. Were all the profiles sequentially numbered? Yes. Was it then easy to scrape 30,000 profiles in a matter of minutes? Well, yes, as a matter of fact, it was. And so you can look at that and you can see a number of things. So for instance, what if all the profiles had not been sequentially numbered? What if they had been GUIDs or UUIDs instead? Well, it would have made guessing to find other profiles borderline impossible. who can come up with an alphanumeric string and then guess subsequent ones based on what you see in a GUID? Nobody, right? Secondly, you notice that authentication and authorization were kind of used interchangeably there. Yes, I should be able to authenticate and view my own private profile, but maybe I shouldn't be able to see other people. But those are two separate functions. And very often in API security, actually, one of the things we see is kind of the lazy pattern of substituting authentication for authorization. So authorization really needs to be done server side, and it really needs to be done with every call. And there's kind of best practices around an authorization model that you can look at. But ultimately here we had a number of things that went hand in hand to lead to that. And so there was this interesting analysis coming out of that State of the Internet report. There were some write-ups at the time. Unfortunately, the one that I found is now archived, but there was a quote that stood out in one of these analyses, and that was, vulnerabilities in apps handling API data are the direct cause of these breaches. Nothing else is to blame. And certainly in that case, when you look at Peloton, you'll see that, there was a authentication and authorization problem, and there was also kind of a data numbering and data handling problem. And so those are application vulnerabilities that were directly at cause of the data breached. But when we look at some of the other events, we'll see that there's actually sometimes more. So also in 2021, we saw a case of this online insurance company called Lemonade. And what we found is that their API was actually exposed in the Google SERP page, so that's search engine results page. With that API being indexed and exposed, anybody could actually click on it, and it did not require authentication. And even worse, there was not an authorization check. And even worse, it actually allowed for read-write function. So you'll see there, full CRUD function. So anybody who got this API, got access to the API, landed on it, and was able to understand how to manipulate it, could have scraped data, could have injected data, modified data, any number of things, malicious things they could have done with the database behind this API. So here, one of the interesting things is that we actually see a combination of a network challenge together with some of those problems with the authentication and authorization. So again, we see multi-vector, but now we see that it's not only in the application layer. So there's some interesting things around that. And in fact, from our analysis, we do know that almost all breach events are multi-vector. Going on to our third case study. So this was a responsible disclosure from a security researcher around Starbucks. Great read. If you ever get a chance, please do check this out. You'll find that it's really a process of kind of almost going down a rabbit hole. So, starting with an API and then noticing that if you pass bad data to that API, you start to get overly verbose errors. And those errors start to expose additional routes on the API. So this is, basically server-side error handling that kind of gives you more and more information with each subsequent call. So the researcher was able to discover a number of API endpoints and routes off of enumeration here, including finding an undisclosed GraphQL endpoint on the API that was almost certainly designed for internal use to allow the developers to kind of check data as they were building out functions. A very easy way to see an entire data set and then build queries that would then be exposed in the API explicitly as kind of stripped down specific data element queries. But in fact, because it was probably designed for internal purposes, that GraphQL endpoint pretty much allowed a select star. And you see here that the researcher accessed almost 100 million customer records. So here, what do we have? What went wrong here? So here we actually have a poor server configuration where you have something that is kind of like, development mode error handling being put on a public API. We have a non-declarative API model, meaning that enumeration really allows for exposure of all these other routes and endpoints. And really the best practice is any public API should only allow the access to the endpoints that are explicitly intended. And then third, from the data perspective, there's a lot of excessive data exposure. Certainly allowing select star is kind of an extreme example of that. And when we look at others, we can see similar things, or we sometimes see more limited data exposure, but still excessive. Last but not least, I think we'll look at one of the most recent ones from one of the most recent full-on breaches as opposed to disclosures. And this was from September of last year, where we saw a telco provider where a network configuration change coupled with a DNS record actually made an API public that was, by many reports, not ever intended to be public. It was intended to be a private API. Again, we see poor authentication. And again, we see incremental account IDs. So one of the things around this, in addition to kind of some of the vectors that we've already talked about, is this practice of kind of incremental account IDs is one of those things that, if you had another stakeholder, another team in the room talking to you about your API design, you would very likely get the feedback that this is a bad practice and you really shouldn't go forward with it. And this talks to kind of an overall trend in API security, which is that developers and application teams are very often left to their own devices to design the APIs, and they don't get a lot of feedback from security teams when they think about threat modeling or they think about the overall design. And as we know from threat modeling is a practice that should really start at that design phase and kind of continue forward. So I'm not going to spend a lot of time on this, but we have published some research around API data breach analysis by primary attack vector, by secondary attack vector. Unsurprisingly, authentication and authorization are primary, and in cases where it's authorization, authentication is often also poor. Again, I'm not going to go into all the details here. Please do check out the research. We've already covered the vast majority of these things. I will just point out, governance really does come into play here. When I think of governance, it's kind of a general term, but it really refers to, where is the API? Does a security team have visibility into it? Is a network team aware of an API being there? Are they aware of its intended use of being public or private or whatnot? So just keep that in mind as well. Last point that I'll kind of raise from our analysis is that API flaws tend to have very broad impact. Why? They're systemic. And so, when you find a problem like this, it generally affects an entire database, right? Or it affects an entire function. So in the case of Starbucks, for instance, that is a very large proof of concept. Nearly 100 million records exfiltrated proves to you that there was a real systemic problem there. So the average number of records per breach is actually well into the millions. And if you think about kind of a $130 cost per record, we get to math conclusions pretty quickly that these breaches are very, very expensive or potentially very expensive. Just last points on this, not industry or geographic specific, but a few industries that do have big supply chains or that do have big third-party models like let's say hospitality and travel with third-party affiliates, et cetera, they do tend to have more API breaches than some other industries. If you want more information, please feel free to check this out. It's on our website. That's the URL. So let's talk about some learnings and then some recommendations. So of course, discovery and visibility are very, very key. But I think policy is something that should be really highlighted here. And when we talk about policy, we're really talking about kind of, bringing all the different parts of the organization into the conversation. So that might be your network team, your security team, et cetera, to understand what those policies are in your organization around it. And then last but not least, I will definitely highlight the importance of a centralized API audit trail. APIs tend to log to a lot of different locations depending on the compute platform or infrastructure that you're running them on. And so the ability to bring all of the logs together in one location will allow you to identify breaches more rapidly, but also to understand the full scope and scale of any breach that does happen. And also don't forget that you need to log from the application layer. If you're just focusing on network traffic, you're usually missing quite a lot of what's going on here. This example here is built off of AWS, but you'll notice that in many cases, if you are only at an API gateway or at a network layer, you don't see the full request parameters or the arguments that are passed to the API. So you may not be able to think about whether that aligns to the authentication or authorization model that you have. And coming back to Outliers to kind of wrap up today's presentation, there's a couple lessons learned from Outliers on that path to success that I think are really relevant to think about. So of course, make sure that communication is cross-team. So we've already talked about the importance of bringing together, network teams and application teams and security teams. But I think it's also important that no team has a blanket veto. So if we go back to that Korean Air case, what did we see? We saw that there were people trying to notify the captain that there were issues. They were off course, that the ILS wasn't working, et cetera. But the captain, in his position, just shut all of that down, right? And you never want that to be the case inside an organization. You want to arrive at a good kind of collaborative, well-informed decision about the design of your API, the architecture, the placement on a network, et cetera. Second, the company that starts earliest has the best chance of success. So API attacks are growing really, really rapidly. And it's only recently, in the last 2, 3 years that the number of breaches has really risen dramatically. Yes, we've seen a 10 plus year history, but over the breaches that we've seen, the most of them have happened in the last, let's call it 3 to 4 year time frame. Attackers know that APIs are a good target. They know that they can get a lot of data because of that data set. But remember, like, you don't need to be perfect. You just need to be good enough that it's not worth their time and effort to go after your API. And also remember, you're benchmarking relative to your peer group. If an attacker is interested and you make it that much harder for them to get data off of your API, the chances are they're going to move on. Don't let that, make you complacent. Don't get lazy around it. But just remember, it's a chance of improvement and it's a process of improvement. And then finally, do your 10,000 hours. The more you work on this, the more that you will get better and better at it. And try to make sure that, teams across your organization are also embarking on a similar journey towards making APIs more secure by design and in runtime. And I think that's it for today. I really appreciate you taking the time. The slides, the video will be available, and you're again welcome to download the report from our website. I'm happy to take any questions. Also, feel free to hit me up just on my email address directly after this. Very simply, I'm just Jeremy@FireTail.io. Thank you very much. That's Jeremy with FireTail signing off from API Days 2023 Helsinki edition.